Awesome. Well, before I guess sort of really dive into it, I want to say thank you very much, everybody, for being here and sitting through my talk on deploying PHP apps with Docker Compose. But before I get started, I just want to take a special moment and say thank you, Oliver, for having me and for giving me the opportunity to give the talk. I really do appreciate it. I have given it before, but I'm trying to spend more time these days on just a few talks and try to continuously improve them each and every time. So, where are we? Right window has the focus. Okay, so without wanting to distract too much from the topic of the talk, if you don't know who I am, if apparently my dulcet tones through this microphone, which is doing all the work for me, if you don't know who I am, I'm Matthew. Perhaps you might detect a slight Australian accent. I hope I still have one after 14 years in Europe. You might know me better as SetterMJD from many years on Twitter, though, as Oliver was saying, more recently I've started using WebDev with Matt, mainly because I figured I spent most of the time talking about WebDev stuff anyway, and maybe WebDev meant more than my name. But I've been writing code for about 20 years, mostly web stuff. I do prefer to forget that a long, long time ago, in a galaxy hopefully very far away, I did write Visual Basic applications backed by Microsoft Access. I don't know if it's a faux pas to say I was young, I needed the money. But it's a time I kind of want to forget about. But all seriousness, over the last 4 to 5 years, I've spent a lot of time, some weeks almost daily, using Docker in some capacity. So given that investment, and without wanting to seem fanboy, a real enjoyment of using it, or perhaps more containers more generally, I thought that it might be worth getting out and sharing what I've learned in the hope that something that I've learned may help someone else use Docker more productively, more efficiently, answer some kind of bug that you haven't been able to get through. So that, plus what I've said before, is the main motivation for the talk. I'm not sponsored by Docker or affiliated with them in any way. If you're interested, you can find me on, well, I was going to say all the socials, on at least LinkedIn and Twitter anyway, at WebDev with Matt, and you can find a work in progress website, webdevwithmatt.com. When time permits, which hopefully I'll have a bit of over Christmas, I'm hoping to complete that. Now, to the talk, more proper. So what will you learn in this talk, which is something that I find important to state up front? That said, I can't guarantee what you're going to take away from this talk. Here is what I hope to impart to you, which in a nutshell is how to deploy PHP applications using Docker, but more specifically using Docker Compose. To drill that down, to get into more specifics there, I'm hoping that you'll learn how to build a Docker-based local development environment, along with how to do some testing, but how to deploy to that environment, how to build a production deployment setup from or based on the development version, how to build and tag self-contained Docker images, which are required for remote environments or anything that's not on your local machine, how to push those images to a remote Docker image registry. That way, no matter where the deployment's made or who's making it, the images that make up the application will be accessible. And also, how to test the production deployment, or I'll say remote deployment, from here on in, hopefully, before you make it. That way, hopefully then helps you to reduce the likelihood of something going wrong. I try to emphasize the testing point, because just for so long, like I guess so many other people, I ran into it works on my machine, but then something on that remote environment didn't work or was different or was missing. So I try to kind of check things as much as possible. Now, the last thing I'm hoping to cover and pass on in this talk is obviously, or hopefully, obviously, how to deploy your PHP application to a remote environment using Docker Compose without a whole swathe of other commands, or a minimum of other commands. So let's get into it. Now, this is all made possible, or the rub or kernel of my talk is made possible by Docker's core architecture, which, quoting the official documentation, which you can see here, is that Docker uses a client service architecture. Your Docker client talks to the Docker daemon, which in turn does the heavy lifting of building, running, and distributing the Docker containers within the application. The Docker client and the daemon can run on the same machine, hence why you could deploy to your local machine with Docker Compose. Excuse me. Or you could connect your client to a remote daemon, so you could deploy to production, staging, testing, or whatever. The client and the daemon communicate using a REST API over Unix sockets or a network interface. Thanks to that, depending on what your application is and what its needs are, you may not need any extra commands such as Docker Swarm or Kubernetes. Did I say Kubernetes? I meant Kubernetes. To be fair, and just to build on that previous point, there are more advanced ways to deploy applications with Docker. But depending on what the requirements of your app are, this approach may be all you need. The main thing to keep in mind is which Docker daemon your Docker client is connecting to. And I just want to stress one last time that I've attempted to sort of simplify things down here just to try and get a whole lot of points in. So if I seem to gloss over something, I've likely done that intentionally. So please just add a question in the chat or ask me later and we can build on that at that point. So next question, why deploy with Docker, especially when there are so many other deployment options built up and refined and developed over 20, 30, 40, however many years now? Well, I'll speak for myself and say that in my own experience, especially in the last 4 to 6 months, after learning about Docker, and yes, as you can see me here, getting a few more gray hairs, and if you can see behind, it's Gandalf the White, but c'est la vie. I found Docker to be often a simpler, more homogeneous way of deploying than I'd been used to in the past, using tools such as Rocketeer, Capistrano, WebAstrano, and rsync over SSH. I found that by using some standardized files and a reasonably small set of commands and subcommands, that I can deploy to almost any application as easily as I could to my local development machine. What's more, so can any other developer on a project, assuming that the files and configuration have been set up properly. I admit that what I'm going to step through in the remainder of this talk is independent of any continuous deployment tools such as Circle CI, GitHub, Actions, GitLab, and so forth, and that when using them, it's not quite as simple as what I'll cover here, but conceptually, deployments can be that straightforward. Now, before we dive in too deeply, there are naturally a few things that you're going to need. Firstly, you'll need a broad understanding or familiarity with Docker, such as terms like image, container, and service. Then, and this, what would you say, I'm kind of speaking in generalities here. If you're using Linux, then you need Docker Engine. If you're on Mac OS or Windows, I guess Docker Engine, or maybe if you find it easier, Docker Desktop. Though on Mac OS, the hate for Docker Desktop and Mac OS, I wouldn't say it's legendary, but it's pretty decent for some pretty good reasons. but sometimes for the perspective of an installer, it can make your life simpler. Next is Docker Compose. Now, I've pointed out here in the slide version 2, and that's the one I encourage people to use. While you can use version 1, and if you install Docker Engine or Docker Desktop, it'll be there as part of the bundle. From recent experiences of deploying WebDev with Matt.com, I found version 2 to deploy significantly faster for the primary reason, or at least as I've come to learn so far, is that it doesn't open as many SSH connections as version 1 does. So because of that, you're less likely to hit firewall rate limits, which further exacerbate that time to deploy. For one example, when I was kind of coming to grips to figure out what was going on, was when I was using version 1, I think my deployment time went as long as 26 to 36 minutes. When I used version 2, I think it was down to 27 seconds. And all things being equal, nothing was different. So that's why I encourage version 2. But I appreciate, or at least last time I checked, version 2 I think wasn't quite on feature parity with version 1, but I've got to check that. The second last thing you're going to need is access to a Docker image registry of some kind, such as Docker Hub, DigitalOcean's container registry, or maybe a self-deployment of Docker registry. So that way you can put your images into that are built and then access them later. And finally, I guess naturally enough, is a deployment server running Docker. For example, maybe a DigitalOcean droplet. Also, for complete transparency, no, I'm not paid to plug DigitalOcean. It's just I've used them a lot lately, so that's what I'm most familiar with, and I felt it most natural to use that in the talk. Now, let's talk about the demo application that I'll use in the talk to sort of help make it more meaningful, more tangible, because every talk, I guess, has to have some kind of demo. This is my demo application. It's a small one which uses the Mezio framework. You can see it here in all its glory. It lists the main cast of Hawaii 5.0 from the 2010 to 2020 reboot, and it shows the actors' profile pictures, their names, and the characters' names. It's not, admittedly, the most sophisticated of applications. Rather, it's actually quite a simple one because it's just for the purposes of a demo. It reads records from a MariaDB database and then renders them, as again you can see here. It doesn't make use of logging, queuing, or caching services. I deliberately chose to do that and keep those requirements relatively modest, just so that they wouldn't distract from the talk's primary purpose of really learning about deploying with Docker rather than doing one kind of thing specifically. However, please let me know in the chat or later on if you feel, I guess as well as we go through the talk, if making a more sophisticated or complex setup would help convey or help with learning about deploying with Docker. As a little side note, as perhaps cheesy as this sounds, I really do love watching Hawaii 5.0, one of my favorite shows. So if you're kind of wondering, like, why is he talking about that? I guess, like, why does the Python community talk about, oh, I've lost it. It was right there. Monty Python. There we go. Sorry. I just totally loved the show, as cheesy as that is. So much so that my wife and I actually got married on the beach in Oahu back in 2012. So there's a lot of connection for me there. I hope that helps it kind of not stand out like a sore thumb. Now, digging deeper, the app will need 3 services for it to function. It'll need a PHP runtime, a web server to serve the static content, and a database server to provide the dynamic information. I've split it up like this mainly because it's just the way I'm used to doing it. You could combine PHP and nginx into one container using Apache, but as I said, this is the way I've done it, and I kind of find it a little bit easier to reason with, but maybe it's just, my muddly mid-40s brain. Now, this composition follows a Docker ethos of one process or service per container. The idea being, you make it as simple as possible to debug something when it goes wrong, and also to build it and maintain it. So now let's, sort of get that bit deeper into the process and start off by creating the directory structure and then development configuration. I usually use a somewhat simplistic structure in the root directory of a given PHP project in a directory named Docker. I don't have a particularly special reason for this other than noticing that it was what other people seemed to do when I was learning from them, and that using it worked for me as well. You can see the structure here on the right hand side of the slide. Inside that top level Docker directory, you can see that there are directories for development and production, which if you then had staging, testing, and so forth, you could then replicate that approach. These are then subdivided for the services within the particular application's configuration. Excuse me. And then within each of the service directories, where relevant, is a Docker file containing the instructions for building the underlying image for each service, if that's required, which we'll cover progressively shortly. Alongside the Docker file are any supporting files for that image, such as default.conf for the nginx image, which overrides the default nginx configuration that comes with that image, and dump.sql for the database service. Now, in addition, I have a Docker compose file for each environment. I don't necessarily name them as I've named them here in the slide, but I thought it might help make the slides that much clearer and sort of simpler to take up. Righty-roo, so let's start working through the Docker files for each of the relevant development services. We'll start off with the nginx Docker file. Now you can see here it has two instructions, so it doesn't really do a lot, but in this simplistic demo application, at this point it doesn't really need to. It starts off by using the Alpine Linux version of the official nginx Docker Hub image. You can, as you may well be familiar, you can base your image on whatever other image that you like, whether that's an official Docker Hub image. I believe there is, I think I read about it just yesterday, GitHub Packages is a competing or a similar option to Docker Hub, or from wherever else that you want, whether that's something you made yourself or something a colleague or friend made, just so long as you trust that image. I find it helpful personally to use Alpine Linux base images, mainly because they're often much smaller than base images that are based on other distributions, such as Ubuntu or Debian, often to the point that at least the base image can be around about 5 meg in size. By doing that, you can reduce your image hosting and transfer costs. You can reduce the time taken to make a deployment. And it's also more or less one of the Docker best practices for writing Docker files. And with all the talk of the climate crisis, it can also be just that little bit friendly to the environment too. Now, getting back to the Docker file, the copy instruction copies the nginx configuration file in Docker production nginx on the local development machine into /etc/nginx/conf.d inside the container. As I said before, I believe that I want to override the default nginx configuration that comes with it. To be fair, I actually just copied the original out and then just changed it a bit. Now this is the configuration file, or well, it's a kind of a cut down one to fit into the slide and still be readable. It isn't, I'd argue, all that special, but in short, it extends what was there originally, such that it sends all requests to slash public slash index.php, and then those requests are then passed on to the PHP service on port 9000. It does some other stuff, but not really all that important to cover for the purposes of the talk. Now, let's look at the PHP Dockerfile. This one effectively is equally as basic as the nginx Dockerfile. It, again, bases itself on an Alpine Linux image, which is the official Docker Hub PHP image, and uses PHP FPM with PHP 8. I would have used 8.1 in these slides, but I actually didn't have time to update them. I think they came out, or at least I heard about them 3 days ago, but whichever. After that, it runs docker php ext install, which is a custom script that comes with the official Docker Hub PHP image, which generally makes it pretty trivial to install a number of PHP extensions. It doesn't do everything though, such as installing the dependencies upon which an extension depends. So if the underlying image is missing those dependencies, such as PDO PGSQL, then the script will fail. In this case, however, the base image has all the required dependencies, so it works. Now, what we also could do here, as it's for a development deployment, is set some relevant PHP configuration options, or install and configure other extensions such as xdebug, which we wouldn't use in another environment, but for sakes of simplicity, I didn't add it into the slides. Now, let's look at the databases Dockerfile. The reason for this is to simplify creating the database schema and load the data into the database inside the image. That way, when the application is deployed, the database is ready to go. I appreciate that there are a host of other ways that you could do this, and in all likelihood, perhaps probably would, such as using a professional database service, such as DigitalOcean's database service, ScaleGrid, or Heroku, perhaps in tandem with a migration tool such as Docker migrations or Laravel migrations. But for simplicity's sake, we'll do it this way. Now, the copy instruction copies a SQL dump file, which we'll cover in the next slide, into /docker entry point initdb.d inside the image. This is because MariaDB, which we're using along with MySQL, when the image is created, if it finds a .sh, .sql, .sql.gz or .xz file in that directory, it runs all the instructions in it. Here is at least part 1 of 2 of the dump file, or part 1 of several. I didn't include all, just it would have taken too many slides. As you can see, it's a small file which I created with MySQL dump and PHP Storm, and it contains the instructions for creating the base schema, or at least part thereof. It also inserts a set of records into the table once it's been created. So I guess in this, if it was for yourself, then all the complexity that you needed to include. Now, with the Docker files and the supporting files ready, let's now work through the development Docker compose file. The configuration for that file starts by setting a persistable file system volume, which is used by the database container. Now, this is important because while file systems in Docker containers are writable, they don't persist changes across container restarts. Now, this is because when a container is started, it uses the specified image that you've set out for it at the time that that image was created, which naturally doesn't contain any new files which were created by your application, nor any changes to any existing ones. So this is not an altogether great thing when you're working with databases or other storage mechanisms such as caching servers. Hence why we're creating a persistable volume where any new files that your application creates or any changes to existing files will be kept across container restarts. We next define an element called services. This element lists the definitions of 3 services or containers which will make up our application. It starts off with the nginx container. Given that it's named nginx, the container will have a matching host name of nginx, though you can set that to something else if you'd like to. The build instruction tells it to use the instructions in the Docker file located in docker/development/nginx to build the image that will be started as the container, which we've already covered. Next, it sets the restart directive to unless stopped. By doing this, Docker will restart the container if it should crash or stop for some reason other than if we intentionally stop that service or the entire set using a command such as docker compose down or docker stop. Now the restart directive, just out of interest, supports 4 values. These are no, always, on failure, and unless stopped. So no is Docker doesn't restart the container for any reason. Always is it will always be restarted, even if you intentionally stop it at some point. This kind of can be good, kind of can be confusing. On failure is it'll when set Docker restarts a container if the exit code indicates an on failure error, and unless stopped, which we just covered then. Now after that, the configuration maps port 80 in the container to port 8080 on the host machine. That way we can access the application through the browser, opening it to localhost on port 8080. But obviously 8080 was just an arbitrary choice on my part because it's what I'm used to using, so you just pick whatever port just most makes sense. Excuse me again. Then the current directory or context is mounted inside the container at /var/www/html, and this just lets us deploy locally on our host machine, yet have the code be accessible to the nginx container. This in turn has the effect of sharing your local directory with the container, I guess rather like Vagrant shared folders, which should make local development reasonably efficient, depending again on your setup. When you make changes in your development environment, whether in your favorite text editor or an IDE such as PHP Storm, then your changes are available in the container almost immediately. So there's no need to manually copy them or sync them because it's just taken care of for you. So just one less thing to think of. Now the last configuration for this container, whoops, I've skipped on too quickly, is to add a health check. Now these, if you're not familiar, determine or help Docker determine if a container is considered to be healthy or needs to be restarted. Now health checks, there isn't a definition of what a health check is in terms of you don't have to run a particular function and so forth. They can be whatever makes most sense, so long as they can determine, yes, is this service or container healthy or not, or is there some kind of problem. In the case of this service, by default, Mezio applications that you create using the Mezio skeleton come with a ping endpoint, which just returns a JSON response containing the current timestamp. So I felt that it was a simplistic way of testing whether the application, at least to some extent, was still working. From the final 3 options, you can see that the health check will make up to 3 curl requests to that particular endpoint every 60 seconds, allowing for a 3-second timeout. Now, if 3 attempts to the endpoint fail, then the container is considered unhealthy and is then restarted. Now, here's the configuration for the PHP container, reasonably similar to the nginx one. I'll kind of skip along a little quicker just to not kind of rehash things that we've talked about too much already. But you can see that it names the service PHP. The build directive tells it to use the dockerfile in docker development PHP, which we've covered. Again, like the nginx service, it's set to restart unless it's stopped. And finally, As with the nginx service, it maps the local directory on a development machine to /var/www/html in the container. Now for the database service, again, it shares similar properties, so I'll try to not focus on those too much, but just on the ones that are different. As with the other containers, we've given it a name, and its build instructions come from the relevant Dockerfile, and it's set to restart unless stopped. It maps the default port for MariaDB and MySQL of port 3306 in the container to that port on the host machine. My reasoning for doing that is, as with the nginx container, so that I can use GUI tools or command line tools to look at the database, check it, and so forth as and when needed, such as the MySQL command line client, or a GUI tool such as DataGrip, or the database tool within PHP Storm. Or I guess you could also add in an extra service that used maybe PHP MyAdmin, or is it PHP pgadmin if you're using PostgreSQL. Next, it sets the environment variables that it needs using the environment setting. Here you can pass environment variables to the container. So I'm setting 3. These are for the database name and for the database's username and password. You can find the list of all the predefined variables for the MariaDB image in the image's official docs. Kind of tried to keep with the Hawaii 5.0 theme there for the database. I realize username and password aren't the most secure, but for the sakes of a demo, I'm hoping that you'll all kind of be nice to me. Now, next, it uses the volumes directive because because using that, any changes that we make or that the container makes, or such as writing files in MariaDB's data directory, which is in /var/lib/MySQL inside the container, will then be written or persisted to our host machine in /data/database inside the project directory's root directory. Whew. And now that we've finished the Docker Compose configuration, let's deploy the application locally using Docker Compose. Now to do that, as you can see in the command here, I'll first approach it after I feel that I'm comfortable with the configuration that I put together by just calling up. And to the command, we pass the file option, which is necessary in this case because the development Docker Compose file is named docker-compose.dev.yml, which is different from the default name of docker-compose.yml. We also pass the build option to tell Docker Compose to build the 3 images from their respective Docker files first, before continuing with the rest of the instructions. Now, after the command runs, this output is specific to Compose version 2. You'll see each of the containers being created and started. This may take a few minutes based on the speed of your connection. However, after the first time, they usually boot in, I think, under a minute, like sort of maybe sub 30 seconds at least for the little application that I have here. If the base images that you're using haven't been downloaded before, however, then Docker Compose will pull them down first and then run the instructions in their respective Docker files to create custom images from them. Then after that, they'll be used to launch their respective containers. Now, regardless of if it's the first time or the 50th or whatever number of times this is, at this point, you'll see here, I'm kind of motioning to the screen as though people could see me. Maybe if I move my mouse, there we go. At this point here, you can see all of the logs for all of the respective containers being printed out to the terminal. Now I do this first so that I can see in the terminal output if anything didn't work, such as I already had something bound on a particular port, whether port 80 or 8080 or 3306. If that's the case, then I'll normally just press Control-C, stop the application, address the issues, try again. If everything works though, then stop it again and start it slightly differently, as you can see here with the D or detached option. Now when this is passed, after the containers start, Docker goes into detached mode where the containers are run in the background, but the logs aren't printed to the terminal anymore. If you want to save yourself a bit of time, then you can use Docker pull to pull down the respective base images first. And then after that, your deployment should go a lot quicker because you've got the base images all cached locally. But now that the containers are running, it's handy to check if everything's working as you expect. And so to do this, because when you run in detached mode, as I said, the logs are not written to the terminal output, to do some simplistic debugging, you can use a combination of docker compose ps and docker compose logs. So the docker compose ps command is analogous to Linux's ps command, which displays process status information. If we run it, as you can see here, it'll show a list of the containers in the configuration, including, for example, their name, state, and ports. This way, as we saw previously, you can kind of quickly see if all of, actually, sorry, we didn't see previously, I was thinking of logs. We can see if the containers are up and running, if they're starting, or if there's a problem with one or more of them that you then need to investigate. If you want to get the status of just one container, then it's the same command as before, but at the end, as I have here, you pass the name of one or more containers to the command, and it will just filter out all the other containers, so you just see the one that you're after, which can be handy. I think one example actually was the MariaDB container, which is quite verbose by default. So if you're not interested in that, you can just lose the things you are interested in all that other noise. Now, let's assume that Docker Compose PS showed that the database container had exited prematurely or unexpectedly, so you want to learn why. Well, to do that, you can use the logs command for that, filtering down on just that container, as you can see here. Now, by passing the follow argument option, I'm getting myself confused, it'll then tail a log similar to Linux's tail command. That is until you press Control-C to stop it. So that way you can view the logs for, in this case, for just one container or service, or if you drop that off, it'll filter for everything. As I said, that's just a simplistic way of doing some initial debugging to sort of see if there were port binding issues, if there were maybe permissions issues, and so forth. Now, at this point, you can see my glorious application again. If we were to run it, assuming that all the services are up and running, they haven't exited prematurely, if we open it in browser, in Firefox, for example, you can see that everything works. So now that we've made the deployment to the local machine, let's have a quick little recap of what we've done. We've created a directory structure to store the Docker files that we need, along with any supporting files. What's more, I like to think it's nicely structured around the environments that we're focused on. This way, if we want to add more environments later, we can build on that existing structure, which I'd like to think, I hope, is intuitive. We created Docker files for each of the 3 services that compose our application, which were later used to create images, which Docker Compose used to launch containers with. We based each image on an existing base image so that we only had to do as little as possible, gaining a lot of functionality right out of the proverbial box. We then created a 3-service Docker Compose configuration, which used the Docker files which we created, one that supported health checks so that it would know if a service was ready or not and could report that information to us, which synced the source files to the running container, yet let us work locally without having to copy over files when we changed them, set environment variables, configured the services to auto restart if they crashed, and made the database service available to local database tools. We learned how to start or deploy the application locally using a single command, and we learned how to do some basic status checking and debugging should something go wrong. So now that we have that development environment base, if you will, in place, let's move on and see how to build on this foundation by creating production files and then making a production deployment. So the first thing that we're going to do is create some production Docker files. There's a point that I'm going to come back to later. I just want to note it for now, is that there are a few different ways to do this, but I've just picked one that I'm more familiar with. We'll start off, as before, with the nginx Docker file. Now, the reason that the file has changed is that in production or any other remote environment, the image needs to be self-contained with all the source, asset, and configuration files that it needs. It can't sort of rely on your local machine to have those files and make them available. Excuse me. The instruction or work dir instruction sets the working directory or the base path within the image where subsequent instructions will operate relative to if relative paths are used. Next, we add a second copy instruction that copies the contents of the current working directory or context, that being all of the application's source, configuration, and related files, into the images /var/www/html directory. I don't have it included in the slides, but you can then filter down which files will be copied by using a .dockerignore file. So I believe that copy instruction as it stands there will just copy everything that's in there. So if you're on Mac OS, it'll copy in ds_store files. If you're using Git for version control, it'll copy in your Docker directory, your Git directory, or .git. So, I'll go out on a limb and say always good to use a .dockerignore file, so that you're just not copying in files that don't need to be there, ones that may contain local credentials that don't relate to production or whatnot as well. And also just keeps your image as small as possible. Then, since we're using an Alpine-based image, we'll use Alpine's package manager, APK, to install the required binaries that the image will need. In this case, Node.js and npm, and then runs npm to install the front-end dependencies defined in package.json, which I'm not going to cover. Then with everything in place, it finishes up, in this case for the application, by running npx and Tailwind CSS to build the application style sheet from the base configuration, instead of generating a sizable development one. Now, if you're not familiar with npx or Tailwind CSS, that's fine. This is just, say, a command that this particular application needs to run. But to get into it just a little bit, the generated style sheet, because I've specified node env production and put the minify option, or included that minify option, then the generated style sheet will contain only the required CSS properties that the application or the front end uses, and it'll be minified. That way, the file in production will be as small as possible and will be generated only when it's actually required. So that way, you don't have to have another file stored and maintained under version control. Now, let's look at the changes to the production Docker file. And thank you, Oliver, for the question. I will do my best to come back to that at the end. Now, this Docker file is kind of long, so I've split it up over a few slides so that hopefully it's a bit more readable. Whoops. So starting off from the from instruction, note that it's virtually the same as the development version, but it adds the string, oops, sorry, as composer here at the end. Now what this does is enable what Docker refers to as multi-stage builds. Quoting the official documentation, with multi-stage builds, use multiple from statements in your Dockerfile, which I'll get into more detail in now. Each from instruction can use a different base image or the same one, and each of them begins a new stage of the build. Because of this, you can selectively copy artifacts from one stage of the build to the next, but leaving behind anything that you don't need in latter stages or in the final image. Now, while I still am kind of, I wouldn't say getting my feet wet with multi-stage builds, but kind of getting completely comfortable, I appreciate that they can add a bit of complexity to the build process, but I feel, and it's been my experience so far, that when done well, they can both simplify and reduce the final image's size. The reason that I've added as composer at the end of the first from instruction is because I only want to build composer in the first stage and then pass that into or copy that into the next stage and not keep all of the dependencies that are required to build composer. Now, given that, it will use two run instructions to install the required packages that composer will need and generates the composer binary. For complete transparency here, I've lifted those instructions, the instructions in the second run instruction from the official PHP compose image. I don't want to try and pass them off as my own work. Next comes the second from instruction, which uses the same base image as before, but I've named this one dependencies. This is because, kind of to reiterate, it will use composer to install the PHP dependencies which the application relies on. As it's the last stage in the build, I didn't have to name it anything, but I thought I would in the talk for the sakes of consistency. To simplify the rest of the instructions, the work dir instructions used. After that, to copy instructions are called to copy the application source files, as with nginx, into the image, and also, in the second one, to copy the composer binary from /user/bin/composer in the composer stage where it was stored to /user/bin in the final stage of the image. Nothing else from the composer stage will remain at this point. All that will remain is what we've copied in and what we've installed or created here. Then composer install is run to install PHP's dependent libraries and packages, and Mesio's development mode is disabled. If you're not familiar with Mesio, don't worry about that instruction. Now, the database image is no different to before, so I'm not going to cover that again. But now that the Docker files have been updated, it's time to build the images from them. To do that, as maybe I inferred there, you use the docker build command, as you can see 3 examples of here, one for each of the images. Now, note the options supplied to each command, that being firstly file, or we could have used the shorter F option, and this specifies the name and the path of the Docker file containing the build instructions for that particular image. Now we're doing this as the Docker file for each of the images or each of the commands isn't located in the directory where the Docker build command will be run. Then we're passing the path to the image's context, which is, if I get my mouse, is the dot here at the end. And all commands will be run relative to that directory. And then finally, we're specifying the tag option, or we could have used the shorter T option to tag the image. Now, there are a couple of things to note with using the tag option. And that is that the tag label starts, in this example here, with web dev with Matt, which is my Docker Hub username. By doing this, when the images are pushed, which I'll cover shortly, then the information doesn't need to be supplied again because it'll be automatically retrieved from the image. Now, if you're doing a slightly fancier setup, you could also supply, say, a Docker registry URL if we were using a service other than, say, Docker Hub, such as DigitalOcean's container registry. So again, it will determine which service you're going to use and then what your username is within that based on the tag that you've tagged the image with. Now, we've also given the image a name and a tag. We can call these whatever we want, so long as they're unique in our account. Ideally, while naming things can be pretty hard, something that is applicable to your particular use case. Now, once the images have been built, we can confirm that they're ready. And we do that by using the docker images command. I promise there aren't too many Docker commands to keep in mind. I've tried to keep them down to as few as is practically possible. So here in this example, you can see the repository and tag names, as well as the image ID, when the images were created, and their size. And just running Docker images, as we see here, will just list everything that you have available in your local image cache, or if you are referring to a registry, whatever in that registry. If you have a long list of images because perhaps you create quite a lot or have created quite a lot, you can use the filter option to filter the output to just the images that you're interested in. In this example here, the available images are filtered based on a combination of the repository and tag columns joined by a colon. I just want to say, if anybody else, excuse me, sorry, I'm not sure what's quite going on there, that whilst from what I've used from my experience with the filter option, it is quite powerful because I believe it's largely based on regular expressions. That said, the documentation for it leaves just more than a bit to be desired, because it says you can do all these amazing, powerful things and then doesn't really follow up with how to do those things and to give you kind of more details. You sort of, at least I feel like, a little bit left on your own, but that's just a little mini rant from me. Now, getting back to some positivity, with the images now built and tagged, we now need to store them in a Docker registry so that they're accessible no matter where the deployment is run from and no matter who is running it. For the purposes of this talk, I'm using Docker Hub, or you can assume I'm using Docker Hub, but if you prefer, as I said, you can set up your local Docker image registry or a commercial service. As you might expect, if we're pushing something, we're going to use the docker push command to do that. Before we can do that, though, we have to run docker login first. So that way we authenticate against whatever registry it is that we're using. As a little aside, if you are using Docker DigitalOcean's container registry, you can call docker login, which will transparently authenticate against the service for you. So you don't have to learn another command, though you can if you want to be more familiar with using that particular service. Regardless of how you do it, after we've logged in, you then push the images using Docker push, as you see in these three examples here. Just to reiterate, we don't have to provide any extra options or arguments to pass the registry URL or the account name to Docker push, as they're retrieved from the image, which we added when we called docker build. Now, we need to update the production Docker compose configuration file, or in this example, create it for a production deployment. Now, I just want to segue slightly and say that the approach that I've taken here is to create two separate sets of configuration files, because the reason for that was most of my experience up to this point has kind of been that way, because I think early on I was maybe a little bit overly enthusiastic, and I got myself muddled up and messed up by using one of the other approaches, which is to have a base set of configuration files with the minimum that any deployment needs, and then a series of supplemental files per environment that either override or extend that base setup. I'm experimenting with that at the moment, and was really encouraged to do so by some of the folks in the Frankfurt user group when I gave the talk originally. I'm going to talk about having sort of two sets at the moment, because it was just simpler in my head to kind of keep them separated and debug them and maintain them. But there are two approaches, and there's also a third option, but I'm not going to cover that because I just really don't have enough familiarity with it. Now, you'll see as we step through that the production setup is reasonably similar to the development setup. It'll have the same services with more or less the same configuration, but there are some key differences to pay attention to. The nginx service, instead of using a dockerfile, now uses the nginx image that we created. The local directories are no longer mounted as volumes for the three services, and as you can see here for the nginx service, instead it now uses a shared named volume named composer dependencies. Now this ensures, though I'm not going to go into much depth on it, but that PHP's dependencies are available to the container, but without duplicating the files. This is the same as we'll see in the PHP container in just a moment. Also, instead of mapping port 80 in the image to port 8080 in the host, we map the standard port 80 on the host as well. Similar to the nginx service, the PHP service uses the image that we just created and the composer dependencies shared name volume. So that way, both of them have PHP's dependencies as and when they're required. And as I sit here, I'm kind of wondering why I included that in nginx, but maybe that's something to come back to later. For the production database configuration, similar to the other two services, the database service uses the image that we created for it. And secondly, it still specifies the required environment variables, but in this case, different to the previous iteration, we're not explicitly setting the environment variables in the file. Rather, they're going to be retrieved from the environment where Docker Compose is run. Or would that be correct? I think the client. Anyway, I won't muddle myself up there and think on the fly. So, as we have to set them, let's do that now. Now, as I'm sure we're all familiar, there are a number of ways to set environment variables. Again, for the sakes of simplicity, we're going to use Linux's export command. As this is a test application, I think there's no stringent requirement to set strong passwords and related credentials, hence using username of user and password of password again. Please don't burn me for using something so simple. Before we, actually, I'm not sure if I come back to that later in the talk, but you could also, if you're using a deployment, a CI/CD tool such as GitHub Actions, you could store those credentials in its secrets functionality, or you could use another secret service such as, I think it's the one from HashiCorp. There's an AWS option and I guess a plethora of other tools. So, set them the way that makes most sense. Now, as with development, before we deploy the application to production, let's test that it works locally. That way we can hopefully eliminate as many potential issues before we actually run our production deployment. Now, similar to in development, hopefully kind of reiterating that you really can just at least a number of use cases just almost use Docker Compose, whether locally or remote. We're going to use Docker Compose up as we did with the development version, but this time we're using the production Docker Compose file instead of the development version. One thing I guess to bear in mind is that depending on your security settings, and I guess this kind of, I should have said this earlier, you'll either have to add your existing user to the relevant group, such as Docker, or perhaps another one, staff, ADM, or admin, if they haven't already been, so that they have sufficient permissions to bind on port 80 as it's a privileged port, or use sudo to obtain sufficient privileges. Now, when your terminal's output stops scrolling, as before, we'll check if everything's working. We could use Docker Compose PS to check that everything's working. This time, again, using the production file by passing in the name of the production file with the file option. If all of the container states are listed as up, then we can be, I guess, pretty sure at that point that the deployment will work. If one of the containers statuses is listed as starting, depending on your health check, give it a little bit of time and then check again, because I found learned with the health check that that initial delay, so you've got to get through that first health check, which is based on, I think it's the delay to actually run the health check and the time between them. But if one of the containers isn't working, then we can check the logs to see what's going wrong. But we'll assume that the deployment locally was a success, so we'd now use Docker Compose down to stop the application, as we no longer need it running. And it is finally time to deploy to production. However, there's one little thing to do before we can do that, and that is to tell your local Docker client, or we'd adjust this for a CI/CD tool, to use the Docker daemon running in the remote host, which by default runs through a non-networked Unix or Linux socket. Now, to connect to it, we can do one of three things, and there are pros and cons to each of these depending on your situation, and I'll kind of touch on these just a little bit. Now, the first thing we can do is set the docker_host environment variable before running a Docker command, or use maybe, I think it's a double ampersand with the command, or export it in one, all in a one-liner. We could use the capital H or host options when running a Docker command, or we could set explicitly a Docker context and then run any command after that as normal. For the sakes of time, however, I'm not going to cover Docker context in too much detail, but maybe just a little bit. But each of the examples each of the examples you can see here, the first one using, the first two using docker_host, the other two using the capital H or host option, will specify the Docker daemon socket to connect to before they run the respective command, which in each of these cases is Docker Compose up. While I have found this to be helpful in building a GitHub action-based workflow, and for running commands locally, I do find it a bit frustrating, as I can forget to set it or accidentally set it incorrectly, which can lead to some mixed results and some confusion. So at least as far as running it locally, I often use Docker context. Now, to quote the Docker context documentation, a single Docker CLI can have multiple contexts. Each context contains all of the endpoint and security information required to manage a different cluster or node. The different context commands, the Docker context command makes it easy to configure these contexts and switch between them. To boil that down, there's a Docker context named default, which is kind of handy for remembering, that references the Docker daemon on your local machine, which has as its endpoint, or the socket where it connects to the Docker daemon, set to Unix :/var/run/docker.sock. So if you don't make use of the docker_host environment variable or H or host options, then you're making use of the default context. However, by using the Docker context set of commands, you can add any number of additional ones, which is handy if you're deploying or your CI/CD tool is deploying to multiple environments. Now, when working with context, you generally only have to do two things, which is create a context or create a new or additional context, and then set it as the one that you want to use from that point onwards. After doing that, you can run your Docker commands as you normally would, and you don't have to remember anything else. So to create a Docker context to a remote host, in this case here, I would use Docker context create, and then remote is just the name I've given it. Then we'll set which socket to connect to. In this case, we're going to connect over SSH using the deploy user at my DigitalOcean droplets IP. I have found and read that Docker Compose, I think, over SSH can be a little flaky, but I've only sort of just started to fiddle with doing it over TCP, so I'm going to skip that for now and just keep these examples as this. After that, after you've created the context, then you call Docker context use and then pass in the name of that context to set it as the default that the commands will use from this point forward. Now, just to check that the new context is being used, you run docker context ls, and if it is, you'll see it in the list as in this example here, with an asterisk after its name in the name column, and that way confirms that is the context that is currently in effect. To return to your default context or your development machine, then you would run, as we did here before, docker context use, and then put default in or whatever the context is that you want to use. Whew. Now, believe it or not, at 6 minutes over an hour, we're ready to deploy the application. To do that, as I said, I was going to use Docker host instead. We set that environment variable, and all in one go, then use docker compose, pass in the name of the compose file to get the instructions from, and then run up and set it to move into detach mode after it's run successfully. As with running docker compose in development, you should see the container start, but this time all of it will be working on the remote Docker daemon, or from the perspective of or context of that daemon. So keep in mind that it may take a bit of time for the first time your remote host downloads the images, but after that, after they're cached, then the application as locally should start reasonably quickly from there on in for any sort of subsequent deployments. You may, depending on how you do it, have to set up the cache or your deployment tool to use the cache the right way though. It may not do it properly by default or most effectively. I assure you we are coming rapidly to the end. Thank you very much for sitting with me so far. So, as always, did it work? Or let's just test. So again, some simplistic debugging. With our deployment now made, it's time to check that it worked. Because we exported the Docker host environment variable previously, we can use the standard Docker commands which we've been using, that being docker compose ps to check the status of the containers and docker compose logs to check for any error messages. If everything's working, then if you load the application in your browser, then using your remote host's IP address, or if you've already set up a CNAME on your host, and provisioned it properly, then you'll see it render as it did previously. Now, let's recap now that we're right at the end, what we've learned, or hopefully what I have been able to put across. So hopefully I've been able to impart several key things, those being how to build application images, how to store images in an accessible registry, how to tell a Docker client which daemon you want it to communicate with, how to build a deployment configuration, and how to deploy the application using that configuration. While there were perhaps a lot of new things to learn about, at this point, using this use case and arguably one similar to it, you're now ready to deploy your application to any remote environment of your choosing, whilst not using a whole stack of Docker commands or Kubernetes or related tools. So hopefully it's easier to keep in your head a lot more than at least what it was for me previously when I was looking at, I think, Docker Stack, Docker Swarm, Docker Machine, Docker, you name it. Now, just to finish up, what about a build pipeline, which I've mentioned intermittently throughout the talk? Well, at this point, as you've just completed the first successful deployment using Docker Compose, while it works, and I don't want to detract from hopefully a good feeling of success at this point, using this kind of approach requires deployments to be performed manually, which arguably I don't think anybody really wants to do, maybe more than a handful of times, especially not at your proverbial late on a Friday or a Saturday night where you'd rather be anywhere else. So naturally, a better way would be to integrate this approach into a CI tool, such as GitHub Actions, Circle CI, or TeamCity, just to pick out a few. I haven't included them in the talk because I just wanted to focus on like the core things you need to do without conflating it with one of these tools. Whew. And that is the end of the talk. Thank you again for giving me more than an hour of your time, which I feel is very generous. If you would like to dive deeper into the topic and you haven't already, I have written a book called, as you can see here, called Docker Essentials, which you can get at dockeressentials.com. It covers the topic in a lot more detail than I've gone through in this talk. For what it's worth, I've based the talk on the book. I like to think it goes into sufficient detail, but it doesn't go overboard. It's also packed with some other tips and tricks and pointers that I've learned along the way and picked up from other people. If you're interested, you can download it for free, dockeressentials.com. Thank you very much for giving me your time. And now, let's go to any questions that you might have. So I'll stop the screen share there. Drum roll. Oh, awesome. I didn't see that.
Cool. Yeah. Brilliant. Yeah, I was saying the drum roll earlier on. So yeah, that was my fault. Yeah, I thought it was definitely, you did just clarify at the end that the ebook is free. So I would definitely not going to lose anything by going in and downloading it.
No.
I'm midway through it, I think. So I'm looking forward to, to go in and finish reading the rest of it. So
if anybody's wondering why it is free, because some people have asked me sort of with this inference of, I think, is it not good? Are you just kind of throwing it out there? I don't know. I guess you don't always have to sell stuff. And I just kind of wanted to give it away just to help, really, because I'd seen so many people get stuck and I had myself. So there's no hidden agenda. It's just there. It's a free-for-all. Yeah. So questions. Should I go through the questions or are we kind of going over time?
No, I think we're still okay. I'm okay for a little bit if you're still okay.
Sure.
Yeah, I know I'd noticed something about, let me remind myself what my question was about installing Tailwind
Sorry.
and npm inside nginx, is there a particular benefit to that rather than having a separate node container? And because that's typically how I would build it, would be in its own separate container. Um, so is there a benefit of keeping it all inside one container, do you think, in terms of nginx?
I swear my water has legs, or it has teeth this evening. Oh, wow. No, I don't think there is. I admit I'm learning a lot by giving the talk again because it's helping me
Mhm.
uh, just realize that I'd gotten a bit blinkered. And this came up previously was, yeah, it's probably better, I guess, to, for maybe sakes of instructions and set up to base it, yeah, on the official or a node or npm specific image, and then share the files perhaps from there. So as I sit here, no, I
Okay.
don't have a, I yeah, it's probably better to do it that way and then simplify everything.
Yeah, so I then it was just before you then mentioned it actually, because I thought, oh well, maybe then you need to do a multi-stage build and say copy this directory from node 14 or something, or from assets directory. But yeah, it was the next slide, and I thought, oh, maybe he's going there, and I've just spoiled it. But there we there we are. So
No, it's cool. Yeah, no, I like multi-stage, at least as I see it, in terms of just keeping things small. But um, yes, in terms of answering to Peter's question, yeah, absolutely. Um, oh, hang on. During the image build, how did I do it? I don't think I have the files available quickly enough. I set up. I think I like GitHub Actions, by the way, though I hope in about 6 months it'll be a lot nicer to work with than it is now, which is kind of change something, push it, pray. Um, but I believe, what did I do? I cloned the source first and then made it available. I'll say that without having the configuration to hand.
Yeah, not sure what should be the order, to be honest.
Give me actually, if you can give me a second, I'll try and find it quickly. I hope I'll have it quickly. Oh, that water seriously has teeth. Um, but I'll know that for next time. Where are we? Actually, I'm going to need a little while. This machine is actually a little bit dated, so it's not as fast as I'd like. Dum-de-dum. Any other questions while this is starting, or is there anything I've maybe any glaring omissions or something that I implied incorrectly, or maybe when I was thinking out loud, maybe confused someone? Because I know I kind of did a little bit of kind of like free thought there, and then I thought maybe I'm confusing things by doing that. So if I have, please just let me know.
nothing springs to mind for me. It's one of those sort of talks that, because I've been doing Docker a fair bit already, I'm sort of familiar with most of the concepts already. So maybe
Mm-hmm.
I can't, yeah, put myself back in most of the shoes from the beginning. So no, for me, I was all my sense.
Okay. I hope that in covering enough, well, I'll try that again. My intention was to cover enough ground and terminology that all the bits made sense. I hope
Mm-hmm.
that I did it in an interesting way and didn't kind of feel like maybe I was laboring it or covering things that perhaps I didn't need to.
Yeah, I think there's a couple of things. I think Docker context was one I hadn't used at all before, so I'm going to look into that one more afterwards.
Mm-hmm.
Docker host I'd seen mentioned, I think more in a Docker machine sort of way. So I think, yeah, I'm interested to see how I could use that in the way that you're suggesting. So I think, yeah, that could be useful.
I think their official line, or at least based on a post I saw, a blog post, I think I referenced it in the book, I think the official line or canon, if you will, is to use like the Docker context command. And the reason they put for that, as I try to find, where is it? There it is. Is that point I hope I made about if you use the Docker host environment variable or the capital H or host options, you may maybe if you've got it in a CD tool, depending how you've done it, you may miss those once, and so you might kind of balk the deployment, or you might have a typo in one but not the others and result in a balked build. So the point was using, if you use Docker context, well, you just set it once, and then you just run the commands as you normally would run them, and there's less kind of, what would you say, cognitive overhead. Though I went with the Docker host environment variable and then used it in the talk, or at least part the way, because I was new to GitHub Actions at the time, and I felt that I had to add, I think, like an extra build layer or build step, and it didn't always seem to work properly, whereas I could just put the Docker host environment variable in the one command, and there was just less fussing about. Though I have kind of come to appreciate using the context command, because it's just set, forget, and do as normal. Now here we are. Where are we? Sorry, it's taken me a bit for my ancient machine to get the deployment YAML file. There we go. Okay, so the process that I've got is, let's get the windows in order there, is I set like this is just what actually maybe I could share that screen. There you go. Here we go. And we'll start the share there. Whoops. Can you see that? Is that big enough?
It's loading for me at the moment.
Oh,
okay.
Hang on. Maybe
Yeah, I can see it. It's a little bit small, but
okay. I was hoping that. Whoa, there we go. Whoa. That's a bit too big. Okay, where we scroll over. Okay, so this is the one that I use for doing a deployment for one of the sites I've got. God, that's a bit crusty and slow. Okay, so it'll fire off when I push to a tag that just starts off, uses semantic versioning. It's a major minor patch, but it has a prefix of V. So basically, to kind of help me think with like version 1.0. blah. It has a couple of jobs. It uses Ubuntu latest, blah, 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 blah. Only PHP 7.4, which I've got to update that. Okay, so to the actual steps. I set a release version because I build images, which I didn't cover in the talk, at least for this, to match the Git tag so that the image and the tag match, so it's easier for me to kind of keep everything in sync. Then do a little bit of a test just that it worked properly. And this here, I believe, starts where I check out the code. So this step here, I think, sets up the process to check out the code, because it links into the repository, the Git repository that this workflow is included with. It then uses this one to set up PHP based on the particular version. So you could set it up for, like, I don't know, 1, 2, 3, 5, however many versions, and includes some extensions. What do we do? I think we set up composer caching here to speed up the deployment and cache the dependencies. It's been a little while since I've looked at this, and I'm reasonably new to GitHub Actions, so I'm a bit flaky on that. Then I think it sets up or runs composer install, keeping the lock file in mind, or finishes setting up caching. then runs it. Then we use Docker build X. I don't think I actually need that because I think that's more for multi-platform builds. So if, for example, maybe you set up, and I'm writing an article on it, maybe you want to use Raspberry Pi, for example, for a local image builder, but you're deploying, which uses ARM architecture, but you're deploying to x86 or whatnot, or some other, sort of multi-platform setup. Then we set up caching of Docker layers to try and speed up the deployment process from one build to the next. Since I'm using, I think I probably answered the question, I'm going overboard, but perhaps for sakes of a working example, since I'm deploying to DigitalOcean, then I install the Doctal tool, which helps with authentication and provisioning and so forth. Install Docker Compose version 2, which I covered in the talk. Log in to the container registry so that I can then push the images after they're built. At this point here, where are we? I thought I did that differently. Oh no, sorry, no, I've got 3 of them. Okay, we've got, I've only got 2 images in the configuration because it's only running PHP, FPM, and nginx. So it builds in this command here, or this step here, and this step here, whoops, the 2 images, and then this step, or this build step, I found pretty cruisy, or pretty cool, because you can build it and you can set the tags you want to use, so any number of tags you want, and the file that you want to use to build it with, and the context, and that you want to push it all in one go, to the remote registry. And here, through using secrets, this is the URL, the DigitalOcean URL. This is what DigitalOcean calls a container namespace or a username, and then my image name, and then the particular tag, such as latest, because I always just use latest in the compose file, but also tag an image at the same time. So if you want to revert back to an earlier release for whatever reason, then digest. I think this is just to check that it worked. Then preparing, because at this point now the images are built, they're in the registry. Now I want to push that from I think the client in GitHub Actions to the daemon running in a DigitalOcean droplet. So set up the SSH keys so that it can authenticate properly. Then pull the latest images, because I think I had some issues with caching or not getting the latest images. And then finally, then using push to DigitalOcean, and then as we have here, using the detached flag and using remove orphan. So if something changed, then you can clean up and remove those and they don't linger. But all the way through using secrets, so there's nothing in this file, so that if the file ever got out, anybody could play with your server or completely do it over. And then this point here, so that when you run the detached flag, what would you say, effectively GitHub Actions then detaches from the containers on the DigitalOcean droplet, and the deployment's made. Yeah, and sorry, I appreciate I've taken everybody's time quite a lot, but that's how I do it. So yeah, I guess doing the checkout of the code first, and then running all the other steps thereafter. And by virtue of how GitHub Actions works, I think generally what you do in an earlier step is available to any subsequent step. I think there are caveats to that, but I think to say that it's available to subsequent steps is broadly fair to say and correct. I hope that long-winded answer helped and maybe also gave an example of how to follow the process in a build tool.
Yeah, I think I found that really useful because I was doing, so typically I've done deployments with Ansible and sort of Antistrano or something, or Ansible based.
Mm-hmm.
So I'm still relying on something that's checking out the code on the server and running. So when I then started looking at doing this for Docker, I was sort of doing the same sort of thing. So still cloning the app onto the server and then using Ansible or SSH commands to sort of run Docker Compose up there. But instead of using the Docker host like you're doing, I sort of found out a mismatch then because CI had a newer version of code that was on the server. And I was a bit like, well, why do I need to do a git pull on the server if it's inside the... So I can see how I can clean up that quite a lot based on what you just shown. So that's really useful.
Cool.
Yeah. And I'm going to look into that build action I think I saw you using as well, because I do some CI testing, some asset building in CI, which I could really, because I do the same thing, they tagged by the git commit SHA. So if I push this one, let's say it's pushed to dev, and it's fine. If I then push the same commit SHA to staging, it rebuilds everything again. So I'm like, surely I'm going to take a look at that action because maybe that's a bit cleverer. And it's like, if it goes something like, oh, I've already got an image for that, I won't rebuild it all, and that would speed up my deployments quite a lot. So I'm going to look into that. And yeah, there's a key scan role that I use, action that I use as well for the Ansible deployments, which is quite useful. So I keep meaning to document that more from an Ansible perspective, but I could see how that would work here as well. So yeah, I got some. I'm going to do some tweaking of those GitHub actions later on. I think see how we can get that, how we can streamline that quite a lot.
Okay.
So, yeah, I found that really useful. Thank you.
All right. Oh, absolute pleasure. That I will admit, I hassled a former colleague and mate, Dave Redfern. If you're watching this, thank you very much, Dave. No, seriously, he was amazing help. But no, just kind of working with each bit. This took me, mainly because I was new to GitHub Actions, I think I'll go out on a limb and say it took me like 3 weeks, allowing for, you know, like other work and so forth, to just get the bits, because I got most of the way through it. But the point where it was actually deploying from the GitHub Actions runner to the droplet, I just kept hitting an authentication wall. So yeah, a lot of kind of streamlining, and I had extra stuff, ripped it out, put more in, ripped it out. So
yeah. Okay, very useful. Okay. Yeah, I appreciate it's getting late for you because you're an hour or so ahead of us, I think, still, maybe. So yeah, thank you. I don't want to keep you any later than you have either. So no, I think you'll appreciate that, your time, and that, yeah, I think Peter already said thank you in the chat. So I'll just echo that. I think it all was very, very useful. I will finish reading the book this week, and I'll look forward to when the courses come out, in due time. Also I'll make sure that I, tweet those things through my account, but also through the PHP South Wales account, and I've put links in Slack already, so hopefully some of us will pick them up there. And yeah, it might be, see how I get on with this for some of my personal projects and some client ones, and I might be pinging you on LinkedIn if I need a hand at some point to see how we get on. So
no, absolutely. And if this is at this point, this is just my first release of that book and the course to follow. It's based on the talk feedback and any feedback that someone wants to give. I'm happy to expand it out if it's maybe sort of too rudimentary or kind of a bit blinkered. So yeah, just let me know what you think. Good, bad, ugly. And I'll do my best to, take it on board. And thank you very much again for having me.
No problem. Any last questions from anybody in the chat? I can't see anybody. Apologies if you could hear kids shouting in the background. I'm not going to sleep. It's that time of the evening. I can't see any. Oh, Alice just says, is the deploy workflow available?
It's
I guess on GitHub.
It's not yet, but it can be. I'm happy to like sort of see if I've got anything sort of specific to me, or make it kind of a bit more kind of like sort of generic names, and yeah, make it available, or maybe kind of whack it into as well an additional supplemental section in the book.
You can copy and paste it from the video that will be on YouTube. Of this, so that's always an option. Yeah.
Very true. But yeah, no, I'm happy to. I'm not sure exactly how soonish, but allowing for your like work and kids, get something out there. Absolutely, because as I said, GitHub Actions. While I am coming to like it, I think in 6 months it'll probably be a lot friendlier to work with, and easier to get up to speed with quicker.
Yeah, I'm trying to think whether someone's given a talk for us on GitHub Actions before. Yes, I think we've had one or two. So,
okay.
Yeah, useful tool for sure. Okay, I think let's wrap it up here. I think again, I really appreciate your time, Matthew. It's really strange because you get to listen to you on podcasts and videos and things for so long. Yeah, I can definitely see why people walk to a conference and go, "I know that voice," because I've been there right now. So
Awesome.
Yeah, awesome. Okay, yeah. Hopefully, we'll when these conferences do start opening up again, hopefully we'll actually meet up in person at some point. That would be brilliant.
Yeah, absolutely.
Cool. Right, well, thanks.
Yep. Where we can listen to the podcast.
So where can you hear the podcast?
Yeah.
Currently, I still have it. I'm all but decided to roll the old one into the new one. I'll pop it into the chat here. The old one is free. Oops, I've got too many E's. freethegig.fm. Long story on that name, which I'll skip. The other one is, where are we? podcast.webdevwithmatt.com. The old one, just briefly, if I quickly could, was like I would sit down and talk to somebody. I think almost every episode. They were largely PHP people, but not always. Such as Gary Hocken, Andreas Heigl, Taylor Otwell, and various others. But people from, I think I didn't release the episode because I kind of lost it. From the creator of, and the lead maintainer of the Kotlin language. But the new podcast is at least so far, me just kind of sharing the experiences I've had, such as something like this in the week that was. But I'm thinking about rolling the Free the Geek podcast into the Web Dev with Matt, and then doing a bit of a mixture. So either of those URLs, you can find me.